Hey y'all! The lesson today here is calculating pH. First, let's take a look at the equation to calculate pH. The equation here is that pH, which is, I wouldn't say is a unit because there is no metric unit involved, is sort of like a rating. So anything below 7 is rated to be acidic. Anything above 7 is rated to be basic. As you move further away from 7, it gets stronger. So, as an example, pH 1 is a stronger acid than pH 2. pH 13 is a weaker base than pH 14. Well, after getting that out of the way, let's take a look at what is the formula for pH. So pH is the -1 times log of H3O concentration. That's what it is. Now, for acid, there is a mathematical or relation advantage because the acid, if you're talking about HCl, H2SO4, HNO3, the ratio of that with H3O is always 1 to 1. So if you have 0.1 molar of HCl, that's 0.1 molar of H3O. 0.25 molar of HNO3, it will be 0.25 molar of H3O. Always going to be 1 to 1. And we'll see that in a sec. So let's take a look at this question right here. What is the pH of 1.6 times 10 to the power of -5 molarity of HCl? First, let's take a look at HCl. And what do HCl do when in water, in an aqueous situation? Well, in an aqueous situation, HCl, being the proton donor that he is, will donate proton to H2O to give you H3O+. And of course, chlorine ion is the other thing that you'll find in this solution. So, if you have 1.6 times 10 to the power of -5 molarity of HCl, since the mole ratio here is 1 to 1, that means H3O is also 1.6 times 10 to the power of -5 molar. So that makes things very simple in this case. And it's always going to be simple when you're talking about acid. So pH is equal to the negative log of 1.6 times 10 to the power of -5 molarity. And this is going to be 4.8. Now, pH do not have units. So, this, as I said, it's not a metric number. It's not really a measurement, even though we say we measure pH, but it's really not a metric measurement. All right, so that's pH. That's how you find pH of acids. So let's take a look at NaOH. Let's take a look at question 2. Now, this is not an acid. Blatantly, this is a base. So instead, of course, we're not going to be calculating for pH, which we can. We will calculate for pOH first. Because since this is a base, pOH is equal to the negative log of OH minus. Alright? So, in this case, you have NaOH. NaOH in the presence of water will break up to give you Na plus and OH minus. Okay? Now, the ratio here is 1 to 1. But not all bases are like that. Sometimes you'll get 1 to 2. Sometimes you'll even get 1 to 3. It all depends. But for NaOH, it's going to be 1 to 1. So let's see. We have 3.25 times 10 to the power of -3 molarity. Since this is 1 to 1, that means OH is also going to be the same thing. So, to find pOH, all you have to do is substitute OH with the number that you just discovered. Nothing much of a discovery here. And your answer should be 2.49. Now you may be thinking, that doesn't look like base. Well, in fact it does, because you have to no, I never said that this was a pH. This was a pOH. So how do you turn pOH into a pH? Well, you need another formula. The formula here is pH plus pOH is equal to 14. So yes, you can call it magic number 14. So to find pH of a base, you take 14 and you subtract that to pOH. All right, and this will give you a number that is more basic looking, I guess. So 11.51. That would be the pH. So hopefully you don't mistake pH and pOH, even though of course they do share a very cool relationship right there. All right, let's continue on. Let's take a look at question number 3. Oh, that's nice. Here's another acid right here, nitric acid. So HNO3, when reacted with water, you will produce H3O and NO3. So if this is 3 molar, and again, of course, this is 1:1. For acid, it's always going to be 1:1. So this is going to be 3.0 molar as well. By putting this into my lovely pH equation, you get negative log of 3. That's a big number. 3.0 molarity is actually a pretty big number. It will go all the way to the negative of 0.477. Now, you may be thinking, is it okay to have a negative pH? And I would say absolutely. pH can be a negative number. You can have pH lower than 0. On contrary, you can also have pH greater than 14. Not a big deal. All right, how about going the other way around? If I was given pH, can I go back and get concentration of H3O+? Of course. What's the inverse of log? Well, the inverse of log is 10 to the x. Well, we won't say x. In this case, we will say 10 to the power of negative pH. That's how you get concentration. Okay? And this concentration can be concentration of H3O. This can be concentration of OH, depending on what you're trying to find out. So in this case, you're looking at the concentration of H3O+, because that's what the question is saying. So that would be 10 to the power of negative 2.6. Hey, by doing that, this is nothing more than 0.0025 molarity. Okay. And since, of course, we mentioned this many times for acid is always 1:1, so whatever this H3O belongs to, the acid will have the same concentration. So it doesn't matter if you're looking at sulfuric acid or phosphoric acid, maybe not phosphoric acid because that is a weak acid and it is being treated differently when you're trying to calculate pH. All right, so let's take a look at one more question here. Okay, you have H3O+, given that pH is 8. So C, again, is equal to 10 to the power of negative 8.1. All right, this is a pretty silly question because this is actually a very tiny number. You get 8.0 times 10 to the power of negative 9. So it's pretty amazing if you think about it. So there should be another question here. Let me just add one more question. Question 6. Okay, this is a bonus, man. It's a bonus. So calculate the pH of barium hydroxide. Now, this changes the game just a little bit. So think about barium hydroxide. Upon being in water, upon dissociation, you get Ba2 plus and OH minus. However, in this situation, you need to balance this. 1 mole of barium hydroxide don't produce 1 mole of OH because it actually produces 2 moles of OH. Balancing. Okay. Oh, looks like this question is missing a concentration here, so let's say this is 0.1, all right? 0.1. So if this is 0.1, okay, since the ratio here is 1 to 2, this is going to be 0.1 times 2. 0.2. Okay, so let's calculate pH. But before we calculate pH, this is a base. Basis produces OH, so we need to calculate pOH first. So pOH is equal to the negative log of 0.2. Right? So let me just very quickly grab my calculator and see what this is. So negative log of 0.2 is 0.7. All right, so 0.7 is the pOH. So to find pH, we're going to take 14 minus 0.7, and the pH is going to be 13.3. So here we go. That's pH of base, especially the fact that some bases can have, that doesn't have 1-to-1 in terms of ratio, in this case 1-to-2. So be very careful here. But as I said, acid, it really doesn't matter, because if you look at an acid like H2SO4, I mean, if you were to react that with water, you're going to get, ooh, what happened there? You're going to get H3O plus, and you're going to get HSO4 minus. So the ratio here is 1-to-1. So for acid, you never have to worry about this situation. Anyway, that's calculating pH, pOH, pH of bases, and hope you guys have a good one. Goodbye.